Well, good evening. Welcome to Space Oddities. Thank you for joining us on this Tuesday evening. We're a bit thin on the ground this evening. I've just got Roger and Michael with me this evening. Nothing wrong with that, of course. So how are you guys? Michael, are you feeling any better?
A lot better, thank you.
Good.
Yeah. Voice is almost there.
Well, that's amazing. but anyway, well, we hope you continue to recover. Roger, you okay?
As far as I am at the moment, yes. No, thank you very much.
Fantastic. Well, what have we got for you this evening? Tonight on Space Oddities, we're going to be taking a tour of the solar system and looking at volcanoes of the solar system. It wasn't so long ago that the only world in the solar system where we knew there were volcanoes was the Earth. And of course, that's all changed in the last few decades. So we thought we'd take a look at exactly what's going on the planets of the solar system or their moons in terms of volcanism. Fascinating subject. We hope you'll stay with us for that. Let's just get all the housekeeping out of the way. First of all, I want to go to the chat and see who we've got lurking in the depths of the chat. Sandra, hi Sandra. Hi Paul. Hi Shelley. Nice to see you. Who else we got? That's about all I can see at the moment in the chat. But if you're new to Space Oddities, thank you for being here. We hope you'll stay with us for more fun and frolics from the depths of the cosmos. And if you are new here, why don't you just say hi in the chat? Just introduce yourself, and we'd love to get to know you. You don't have to say any more than that, just hi, because we'd like to know who you are out there. And we hope you've all had a fantastic week. We had a lovely week here in Spain. We had a bit of a cold couple of days last week, but now it's back to t-shirt weather, 22 degrees, not a cloud in the sky today. Absolutely beautiful autumn we're having here. But you don't want to hear about that, I'm sure. So no, definitely not. Definitely not. So anyway, let's just get a few things out of the way. If you would like to support Space Oddities, first of all, most important thing you can do is subscribe. So if you haven't subscribed to the channel, about 76% of our views we get on YouTube are from people who aren't subscribed. So it would really help us if you could just subscribe, totally free. Just hit the subscribe button. You don't have to do any more than that. And that will really help the algorithm notice us more in terms of subscribers. Also, you can support us in a number of different ways. If you look under the chat window, you will see the super chat icon, the one with the $sign on it, where you can make a donation directly to Space Oddities. That's one way of doing it. You can, of course, support us in other ways. You can buy us a coffee, and you can scan this QR code to go right to the Buy Us a Coffee site. And you can buy us caffeine for a very small price. And that helps us, A, keep going in terms of caffeine, and B, keep the show on the road. You can also buy some wonderful, totally indescribably wonderful merchandise at the Space Oddities shop. Again, you can scan the QR code here, or you can click the link that should have just appeared in the chat. And don't forget, winter's drawing in. Well, for you guys anyway. You can buy your Space Oddities hoodies for the colder weather, and you can also buy t-shirts in preparation for next summer. So again, you can scan the code or click the link in the chat. So we're going to kick off right away with today's feature, which is volcanoes of the solar system. Unfortunately, Lou can't be with us tonight. Daz can't be with us tonight. And Tom said he was going to try and pop in. So we hope he will turn up. No news this week, I'm afraid. There are only a couple of news items. I'm going to hold them over till next week. Nothing that important. But we have got coming up later, of course, our regular features. We've got Constellation of the Week. And we have Einstein of the Week, our weekly delve into the insanities of social media. So we hope you stick around for those and that you enjoy them. So let's make a start with volcanoes of the solar system. Now, as I said, a few decades ago, the idea that there could be volcanoes on other worlds, let alone active volcanoes, was quite ridiculous, or seems so. But we now know that the solar system is full of volcanism of one form or another. And this all tells us about the development of planets, the development of moons, what processes are going on. So let's just have a look on around the tour of the solar system. Just give me 1 second to get where I need to be. There we are. Okay, so volcanoes of the solar system. So to start off, we're going to look at a world with a wide variety of volcanism. That is the Earth, of course. Now, here are some common types of volcanic eruption on the Earth. It's not an exhaustive list, just the main ones. But as we know on the Earth, volcanic eruptions can take many different forms, each with its own unique characteristics. So the first one is a type of eruption called a Plinian eruption. And these are named after, as you may know, Pliny the Elder, who documented the 79 AD eruption of Pompeii, which buried Pompeii and Herculaneum under ash and volcanic debris. These eruptions produce towering columns of ash and gas that can reach high into the stratosphere. Other examples of this include the famous 1883 eruption of Krakatoa, the 1980 eruption of Mount St. Helens, and the 1991 eruption of Mount Pinatubo. Phreatic eruptions are steam-driven explosions that occur when magma suddenly and violently interacts with groundwater or surface water, creating huge explosions of steam. Now, this is New Zealand's White Island volcano, where in 2019, 22 tourists were killed in a sudden phreatic explosion. Most were killed in the explosion or by the huge cloud of superheated steam expelled by it. A further 25 people suffered extreme burns but survived. And believe it or not, I think the court cases for that are still going on. On the other hand, effusive eruptions are much more gentle, with lava flows that build shield volcanoes over time. And you've got some very good examples of shield volcanoes with Hawaii and Iceland, both of those being examples of islands built by effusive eruptions. And then lastly, named after the constantly erupting Italian volcano off the island of Sicily, Strombolian eruptions feature moderate explosions and lava fountains, often from small, steep-sided volcanoes. Examples of these are Mount Etna, Mount Erebus in Antarctica, and both of these regularly erupt in Strombolian eruptions. In fact, Mount Etna is more or less constantly erupting, as we know. So there's our baseline for looking at the solar system. How do other worlds compare? Well, the next obvious place to go is not too far afield in the solar system, the moon. And the moon's surface is dominated by dark plains, which you probably know are called mare. These are basalts, a type of volcanic rock formed 3 to 4 billion years ago through extensive volcanic activity. There's been data from spacecraft that have landed on the moon over the last couple of years that, in fact, volcanism died out on the moon, possibly a lot more recent than that, maybe as recently, in inverted commas, as 2 billion years. So it looks at the moment like that the whole idea of when volcanism ended on the moon may need a bit of a rethink. In addition to the mare basalts, the Apollo missions also discovered orange and green volcanic glass beads, which are remnants of the moon's fiery past. However, because the moon's volcanic activity has been extinct for, at least 1 or 2 billion years, this indicates a significant cooling and reduction in internal heat over time. And exactly why the volcanism on the moon stopped is still very much open to question. And these features provide important clues about the moon's geological history and evolution, including its early period of intense volcanic and tectonic processes. So having done the Earth and the moon, we're going to now go around the planets, and we're going to start at the beginning, if you like, and have a look at Mercury. Now, Mercury's surface is dominated by ancient lava flows that cover around 40% of the planet. These smooth volcanic plains were formed by massive eruptions billions of years ago. Irregular depressions on the surface mark the sites where these volcanic eruptions occurred. Mercury's volcanic activity ceased around 3.5 billion years ago, and the planet's been geologically dormant since then. This makes Mercury a sort of volcanic ghost, a planet with a volcanic past but no present-day activity. And we do believe that Mercury is entirely dead as a world with no activity going on whatsoever. So let's turn our attention to Venus, or Hell's Furnace as it is otherwise known. because of its incredibly hostile environment with surface temperatures over 450 degrees C and crushing atmospheric pressure. Mars Mons is the largest volcano on Venus, standing 8 kilometers tall. It's a massive shield volcano formed by highly fluid lava flows. And some other features include pancake domes. These are a unique type of volcanic feature found on Venus. We don't see them anywhere else, created by the eruption of extremely viscous lava that spreads out into flat circular shapes. There's evidence that Venus has experienced volcanic eruptions within the past few decades, suggesting the planet is still geologically active. And there's a growing body of evidence that there may be as many as 26 volcanoes currently active on Venus. Of course, it's very difficult to observe Venus from the Earth because it's shrouded in its thick carbon dioxide atmosphere. But telescopes and radar measurements have indicated that there may still be quite a few volcanoes erupting on Venus, although that has not been confirmed. Moving on to Mars, the volcanic giant. Olympus Mons, of course, we're talking about, which is the largest volcano in the solar system, standing at an impressive, 25 kilometers in height. That's over 3 times taller than Mount Everest. The base of Olympus Mons spans an enormous 600 kilometers, and that's roughly the size of the entire British Isles. This colossal volcano has been dormant for an estimated 100 million years, with the last eruption occurring in the distant past. And Olympus Mons is a truly staggering geological feature, showcasing the immense scale and power of volcanism on the planet Mars. Olympus Mons is not simply a shield volcano, it's the ultimate expression of what a shield volcano can become on a world without plate tectonics. On Earth, the closest comparison is the Hawaiian hotspot, where slow-moving Pacific crust allows repeated lava outpourings to build very broad, gently sloping volcanoes such as Mauna Loa. Olympus Mons follows the same principle, but on a far grander scale. And obviously, islands like Hawaii and Iceland are dwarfed by comparison with Olympus Mons. You see, the thing is that Mars never developed the mobile tectonic plates that constantly shift Earth's hotspots sideways. Instead, the Martian crust remained essentially fixed over its mantle plumes. Lava could erupt from the same location for hundreds of millions of years, stacking flow upon flow. The result is a mountain 3 times taller than Everest, with flanks so broad and gentle that a cyclist could ride up part of the slope without even noticing. On average, the slope of Olympus Mons is only about 5 degrees, so you could walk up Olympus Mons quite comfortably. The only problem is that around most of its base is a solid cliff up to a couple of miles high, vertical rock, a couple of miles high. So once you've got up that somehow, you would have quite a gentle walk to the summit. And unlike stratovolcanoes such as Mount Fuji or Mount St. Helens, which grow steeply and erupt explosively, Olympus Mons formed through quiet, effusive eruptions of runny basaltic lava, more like Hawaii than Iceland. It also developed an enormous summit caldera system as the underlying magma chambers slowly emptied and the surface collapsed. The vast lobed apron around the base is unique to Mars. It likely formed from episodes of gravitational collapse as the volcano spread outwards over weak crust and ancient sediments. This feature has no true Earth analog, underscoring how planetary conditions shape volcanic architectures. And what do we think, Michael and Roger? Do we think that Olympus Mons is one of the classic, most outstanding features of the solar system?
Oh, definitely. Yeah.
Yep.
Yeah, it's an amazing structure, and I'm sure one day people will ascend it because that's what you do. Yeah, definitely. I wonder who the first person on the top of Olympus Mons will be, but I think that's some time off yet, though. But you can see here, in comparison to Australia, I mean, it's absolutely giant. So there we are. Okay, where do we go next? Well, logically, we move to the outer planets, but of course, just to finish off the Olympus Mons, there is truly nothing like it in the solar system anywhere else. So these are just some lovely shots of Olympus Mons. A little bit cratered on the top, and central depression on top of the volcano, on top of the caldera. An amazing feature. So let's move on to the planets. Of course, no volcanoes on Jupiter because it has no solid surface. But instead, we come to Io, which again is unique in the solar system. It's Jupiter's most volcanically active moon, with over 400 constantly erupting volcanoes. And these often spew plumes of sulfur-rich material up to 500 kilometers high, which is quite amazing. But of course, due to the low gravity, it can do that. And it's a truly unique and fascinating world in the solar system. And on Io, volcanism is powered not by hotspots or plate tectonics, but by Jupiter's immense tidal forces flexing the moon until its interior melts. Io hosts vast silicate lava lakes, and you can see one here. This is an actual image, or rather a reconstruction of data to form the actual image of one of those amazing lava lakes. And it's quite an incredible image. And as well as the lava lakes, we have volatile-driven sulfur eruptions, towering umbrella-shaped plumes, and broad lava fields. Many of its vents sit inside complex depressions called paterae, some containing lakes of molten rock miles across, like the one you can see here. But in simple terms, Io's volcanoes are tidal furnace volcanoes, a category with no true analogue on Earth. This mechanism for generating these volcanoes simply doesn't exist anywhere else except on Io. So it's another unique world. And staying with Jupiter, we have to talk about Europa. And it's got a fascinating hidden world, and it's covered in an ice shell. We don't know the exact depth, but hopefully Europa Clipper and the Jupiter Icy Moons Explorer JUICE will establish when they reach Jupiter, both late in this decade. And that ice rink at the moment is anywhere between 15 to 25 thick, and it's a frozen crust covering what we believe vast subsurface ocean that's over 100 kilometers deep. And in fact, Europa has got more water inside it than all Earth's oceans put together, we believe. But those two spacecraft, which are currently en route to Jupiter, doubtless tell us a lot more. And obviously that makes it a prime candidate for some sort of potential extraterrestrial life. The cracks and ridges in the ice shells suggest cryovolcanism, water plumes erupting through the crust from the subsurface ocean. So cryovolcanism is unlike volcanoes on Earth, which are generated by heat. Cryovolcanism means that they either expel ice or water due to the cold temperatures. And the energy, as we said, comes, as with Io, from Jupiter's gravity. That's the powerhouse behind the tidal flexing of Europa's ice shell. You can see very clearly in photographs that ice shell is moving. It's like ice flows, if you like, at the poles on Earth. And that all of that energy is coming from Jupiter's powerful gravity, tidally flexing the crust. We move out to Saturn now, and a world that absolutely fascinates me, for one, Enceladus, this little moon of Saturn, which is again one of the most incredible places in the solar system. It's known for its dramatic geysers, or geysers, I guess, if you're American, erupting from the South Pole. This was discovered by the Cassini spacecraft, and the material that is being ejected in these enormous geysers goes on to form one of the rings of Saturn, the E ring. And these geysers are fed by fractures at the South Pole, which are known as tiger stripes, in the moon's icy surface, and they constantly spew water vapor and ice particles. But beneath the icy shell, Enceladus does have a warm interior with hydrothermal vents similar to those found on Earth's ocean floors. Now, we know this because Cassini sampled one of the plumes of ice and water, actually flew through it in a very daring move. And we know that the particles in that have been in contact with rock on an ocean floor. And therefore, it's another candidate perhaps for extraterrestrial life. Because one idea that is quite prominent when we look at the origins of life on Earth is that it originated near hydrothermal vents on the floor of Earth's oceans. But also, as well as that, the plumes from the geysers have been found to contain complex organic molecules, which again suggests Enceladus may have the ingredients for life. It's intensely cold, of course, but we know of extremophile organisms on the Earth that can survive in freezing temperatures. So it's not beyond the realms of possibility that we've got all these chemicals that you can see listed here, all these elements that the potential certainly for life is there. We need to get back to Enceladus to take a closer look. And moving out from Saturn, well, we bypass Uranus because there doesn't appear to be any cryovolcanism on any of the moons of Uranus that we're aware of. So we move straight out now to Neptune, and we move to Neptune's moon Triton. Its largest moon, in fact. It's known for its remarkable geological features. And Triton has a retrograde orbit, meaning it orbits in the opposite direction of Neptune's rotation. This suggests it was likely captured from the Kuiper belt. The moon's surface also features a unique cantaloupe terrain, as it's called, you can see here. It's sort of a dimpled cryovolcanic landscape, unlike anything else in the solar system. These features make Triton a fascinating and dynamic world, providing clues about the formation and evolution of our solar system. Now, it does host these, like Enceladus, dramatic geyser-like plumes, first seen, in fact, and only seen so far by Voyager 2. They're not like Earth's hot water geysers because it's simply too cold. Instead, what happens is that sunlight penetrates a thin layer of nitrogen ice and warms dark material just underneath it. Now, the nitrogen vaporizes, pressure builds, and gas bursts through the surface, carrying dark particles high into Triton's frigid skies. Voyager actually managed to capture a couple of camera frames showing one of these geysers in action, although they didn't realize it at the time. It's only when they looked at the photographs afterwards that they realized they'd actually captured one of these geysers in action. So we know that they're definitely there. Now, those plumes can rise about 8 kilometers and drift over for 100 kilometers downwind. So on Earth, the geysers are driven by deep volcanic heat, boiling water underground. Triton's eruptions, by contrast, are powered by sunlight and trapped nitrogen gas. It's a cryogenic analog to Yellowstone, if you like. It's like Yellowstone, but a cold Yellowstone instead of a hot Yellowstone. And don't forget, the temperature here is near minus 235 degrees Celsius. One of the big surprises of our initial reconnaissance of the solar system from the Voyagers in particular was that worlds that we thought were frozen and immobile with no activity actually have activity, even though they're that far from the sun and they're that cold. This was completely unexpected, but it's one of the major points to come out of our reconnaissance of the outer worlds. Where do we go from there? Well, of course, we end up at Pluto and its ice volcanoes. And on Pluto, we've got this amazing landscape discovered by the New Horizons spacecraft in 2015. And there is activity. Pluto has glaciers. Pluto has movement. Pluto evolves. And one of the things that New Horizons discovered is a feature called Right Mons, which is a massive 4-kilometer tall possible cryovolcano, although it's not active at the moment. And again, this erupts icy materials instead of molten rock. It's probably a mixture of water and ammonia, not your traditional sort of silicate lava. This young geologically active surface of Pluto has surprised scientists, indicating recent volcanic and tectonic processes of this distant world. And all of these provide clues about Pluto's internal structure and heat flow, and the potential for cryovolcanism on other icy bodies in the solar system. And Pluto, again, is strongly suspected of having an underground ocean, although its extent and depth and size and everything is not known if it's a global ocean. But the way that Pluto's crust is moving indicates that it is in fact floating on some sort of ocean deep under Pluto's surface. So let's have a look at the important thing for volcanism, which are the heat sources. So radioactive decay of elements like uranium, thorium, and potassium has been generating heat within planets and moons for billions of years. Now, this internal heat source is a fundamental driver of geological activity and the evolution of planetary bodies. On the other hand, tidal heating from the gravitational pull of giant planets like Jupiter and Saturn can also create significant internal friction and warmth in moons and smaller bodies. So even after a planet forms, the residual heat left over from its initial creation continues to radiate outward over time. These three key heat sources, radioactive decay, tidal heating, and residual heat, are the engines that power the internal activity and dynamics of many worlds in our solar system. So, what have we learned from all this? Well, volcanism across the solar system takes many forms. On Earth, heat from within drives both gentle basaltic flows like Hawaii and explosive stratovolcanoes such as Fuji. Mars built Olympus Mons, the largest volcano known, through long-lived gentle eruptions on a stable crust. In other words, one that wasn't moving around, doesn't have plate tectonics. Venus shows vast lava plains and domes hinting at ongoing activity. In the outer solar system, volcanism turns icy. Enceladus and Europa vent water vapor from subsurface oceans. Triton erupts nitrogen jets warmed by sunlight, and Io, tugged by Jupiter's gravity, erupts molten lava more fiercely than any world. Volcanism, it seems, adapts to each world's nature and energy source. And this realization that there is this incredible variety of different engines powering different types of volcanism in the solar system has been an amazing discovery and has taught us a lot about the planets and their evolution and how those volcanic systems have developed over billions of years. So there you are. That's our look at the volcanoes of the solar system. Hope you enjoyed that. And viewers, if you have any particular favorite of those, anything you want to tell us about, please put it in the chat, because we're discovering new things about volcanism on these outer worlds all the time, and it'd be interesting to see where this science goes over the next few years. So there we are. So that's volcanism in the solar system. It's something I'm sure we will return to at some point. So let's have a look and see if there are any questions. Paul's got a question. Is Triton's plumes similar to the plumes near the poles of Mars? I'm not quite sure what plumes you're referring to near the poles of Mars. Is this something new? I don't know. Roger, do you know anything about plumes near the poles of Mars?
No idea.
No,
we didn't cover that in our Mars month.
no, we didn't. Oh, okay. Not quite with you there, Paul. Perhaps you could tell us a bit more, because it's not something I've come across. Interesting though. Thank you. Right. Any other questions? Anything else? Anybody want to say? Oh, we've got a few comments here. Yeah, Paul says, I remember it being a big surprise when it was realized just how active Io was. So unfortunately, it's also a very hostile environment. He goes on to say, yeah, it is. It's an incredibly hostile environment, not least because of the intense radiation that it sits in from Jupiter's radiation belts. And if you remember the film, the sequel to 2001, which was 2010, the year we make contacts, the Discovery is orbiting Io, and it gives you a good idea of what it would be like to be in orbit around Io. Very well done, I thought. And it is an intensely hostile environment. Anthony Piñate, saludos buenas. Muy bien, muy bien. Estamos muy contentos de que estás aquí, y espero que te gusta nuestra presentación. Es muy bienvenido a Space Oddities. So yeah, the last couple of decades have been amazing for discovering these worlds, and especially on Pluto, because, you know, before New Horizons got to Pluto, we really didn't know what to expect. We had very poor images of Pluto. Even the Hubble Space Telescope could only give us a sort of a pixelated image of Pluto, and it was a revelation what Pluto is. It's an active world with cryovolcanism and moving glaciers, and I think Pluto is amazing. To that end, in January, we will be pleased to welcome Dr. Alan Stern, who was the man behind the New Horizons mission, to Space Oddities. He's coming in for a chat, and he's going to be talking about, amongst other things, what we've learned about Pluto since New Horizons. What has the data revealed? Because don't forget, when they do planetary missions, the data takes years and years to analyze. And we've learned a lot about Pluto since the flyby in 2015. So we're going to be delighted to welcome Alan to Space Oddities at some time in January. We haven't confirmed a date with him yet, but we will do. So you've got that to look forward to in January. January also marks the 20th anniversary of the launch of New Horizons. So it's a nice tie-up with that. We're going to be talking a lot more about Pluto in January, generally.
There is a talk, a Zoom talk by Alan Stern on the 15th of November. I think it's
is there? Great.
Yeah, run by the Federation of Astronomical Societies.
Oh, great.
Doing a talk on that, yeah. And I think tickets are still available for that.
Right.
So, yeah.
Great.
So,
is it going to be on YouTube at some point, do you know?
Probably. I'm not sure about that yet. So
okay.
I'll find out.
Right. So we'll, if you could, then we can tell people about it.
Yeah.
Thanks. Shelley, thank you for your question. What about basalt and copper? In which context are we talking here? Obviously, on the outer worlds, there's no basalt because it's a volcanic rock that's only formed by heat. And in fact, my local geology is all basalt. And I live within sight of a volcano, which is great. I always wanted to live near a volcano. Luckily, it hasn't erupted for 9 years.
Not active, though.
Yeah. But it's all basalt here. Basalt is a very hard rock. I know this from when I fell onto a lump of it and snapped my femur. And it's totally unforgiving. And it was quite an experience. But I must just tell you this. I was laying there shouting for help. It was 10 o'clock on a Monday morning, nobody around. It was just by our local pond.
Yeah.
And nobody around at all. So I was sitting there shouting away, help. But realized then I was shouting in English. So I thought I'll shout it in Spanish. That'll probably be better. but there was nobody. My wife's nephew happened to walk by. I couldn't see him because I was pointing in the other direction. He thought I was a tramp laying on the ground and moved on. And yeah, great. But then I just rang the ambulance, and my wife rang the local police, and they turned up first. And they said, "You're English?" And I said, "Yes." And they said, "What do you think about Brexit?" So we're having this chat about Brexit. They wanted to know all about Brexit. And then the ambulance crew turned up a few minutes later, and the police said to him, "He's English." And they said, "Oh, what do you think about Brexit?" So I'm laying on the ground. I'm laying on the ground with my feet pointing in different directions because my femur had entirely snapped. And they just wanted to have a chat about Brexit. And after about 15 minutes, I said, "You know,
Yeah.
you go to the hospital." And they, "Oh, you want to go to the hospital? Yeah, that's fine. Let's go." Weird. Yeah. Anyway,
I slipped on wet grass and fractured my fibula.
Yeah. Yeah. Anyway, Shelley, no basalt in the outer moons. Copper's not something that you get ejected in volcanoes of any type. But thanks for that. Let's just have a look and see what else we've got down here. The Deep Burrito says, "Afternoon all. I remember putting my name down on a list that went on the New Horizons spacecraft. Anybody else did that?" Yes, I did that.
Yeah, I think I did that as well.
Yeah. Me and my daughter's name on that. So part of it. I've also got my name on Titan. Because my name went on the European Hygiene spacecraft that landed on Titan. So long after I'm dead, part of me will always be on an alien moon, which I think is incredibly romantic. So yeah, I did one recently as well. What was the one I did recently? I can't remember. There's one at the moment at NASA where you can put your name on a spacecraft.
I remember putting it on the Mars 2020 rover, the Perseverance.
Yeah, I don't know. I've done so many. But yes, I mean, it's all free. Go to NASA, you can find them easily enough, and your name will be written onto a chip.
Immortalized.
The spacecraft. So
immortalized.
Immortalized, indeed. And the funny thing about the Huygens one was that they asked you to put a message as well as your name. So it would be your message to the future, if you like. And some of the messages were incredibly unimaginative. Things like "Hi from Bob."
Yeah, right.
So someone just said she's just done hers on Artemis 2.
Yeah.
Oh, that was the one. It was Artemis 2.
I've done that one.
Good evening, Ian. Nice of you to join us. And
hi, Ian.
Calling you now. So great. All right then. So we're going to move on. If you do have any other questions about volcanism, or you think you've got a particular favorite, then put it in the chat. We'll do our best to answer. So what we can do now is go over to Roger for this week's night sky and the ever popular viewers gallery.
Right.
So do bear with us a moment. We've got a slight technical problem this evening. But there we are. So what's in the night sky? Take it away, Rog.
Okay, so we're full screen on this now, are we?
Yes,
we are.
Right. Okay, so we are coming up through the first full week of November, and obviously we've got bonfire night tomorrow. But we are working our way up through also on bonfire night for a full moon.
Well, some people think it's tonight.
Well, it just depends on where you are, really, what time zone you're in. So, looking through the night sky, I've got this on a bit earlier now because it's darker earlier. This is for 10 p.m. And as we can see, we've now got the summer triangle now setting over in the west. And we've got Square Pegasus and Andromeda dominating almost overhead, with the winter constellations now coming up through from the east, with the moon coming through there. We've also got Jupiter coming up quite nicely as well. So things are all moving along. It just depends on whether you can see them with all these cloudy, wet, windy evenings. And when we've got coming up before sunrise, we've also got Venus coming up through as well. So some nice objects to see should you be up early. So we've also got around these few nights, we've also got the Taurid meteors. So that can be quite good. But obviously with the full moon coming out through, it will be a bit of a challenge with all that moon glow in the night sky. So if you can find something moving about, that's probably what it is. So tomorrow is a full beaver moon, as we liked what we have from all the Americans across the water, naming all these different themes. So it's also a little bit bigger, which people like to call as a supermoon. And it's the largest one that we've got of 3 consecutive ones from October, November and December. So not that we'll notice it too much unless you're photographing it. You might see it a little bit larger in your camera, but apart from that, you won't really notice it. But it will be a little bit brighter as well. So there we go. So we've got Jupiter coming up through into Gemini. And we've also got coming up through when they are closing up together, a waning gibbous moon. So that will be on the 9th of November. But before all that, we've got Mars and Mercury coming up through. So they will be quite close to the Sun, unfortunately, to see them properly. But if you can get a glimpse of them, then all well and good. And as you can see from the illustration here, we've also got Comet Lemon in a Fucus up above. So Mercury and Mars are quite low down anyway. So with that being quite low and near to the Sun, which is further over to the right here, it might be a bit of a challenge, but they are there. But be very, very careful if you do try to look for them, because they will be getting quite close to the solar glare. And when you do see Venus in the morning, you might notice it's near Spica in Virgo. So we've got the Leonids coming up through in another week or so. So just be warned about that. So that can be quite a good one. They're exceptionally fast-moving meteors, which are can be quite spectacular if you do get to see any of them. So fortunately, the moon will be at a very thin phase at that point, so things can be quite good for meteor spotting. So onwards with the gallery. Oh, and no, that is the wrong. Oh, we've got the wrong slide there.
You can't get the staff, you know.
They can't get the staff. Oh, what's happened here? I seem to have got the wrong presentation for the gallery here.
Oh, okay.
Oh, right. We'll have to get back to that in a minute. Let me go and find that while we look for that.
We're going to move on with... It's that time again. It's our weekly delve into the nether regions of social media to see what insanities people have been coming up with in our regular feature, Einstein of the Week. So just give me 1 second and I will do the business. Okay, so Einstein of the Week for this week. Got a few here for this week. So first of all, somebody talking about the moon. And it may interest you to know that the moon is flat. The dark side is the bottom of its firmament away from us. And when you see moon landing deniers, flat earthers, especially flat earthers, talking about the firmament, they seem to think it's something real, whereas, of course, the word firmament is simply another word for sky. But they think it's something solid for some particular reason, peculiar reason that we can't get through. So I don't know. I don't know if apparently the moon has a firmament as well. So So there we are. But not to be outdone, somebody else has another go about the moon, and particularly about the dark side of the moon, which, as we know, there is no dark side of the moon really. And this person said, I believe the reason why it's called dark side because it may be bombarded by meteors so many times that it's deformed. How much moon do we have on that side? And how much more can stand her ground? Yeah.
I like it.
Yeah. So the far side of the moon is deformed by all those meteors. Well, interesting idea, but completely mad.
Completely wrong.
Yeah, a bit wrong. Then we move on to somebody who wanted to ask a question, and the question was, where is the 93 million miles of cold, dark space between the Earth and Sun, and why does the Sun look so small as it's right above the Earth plane? Well, I replied to this person and said that the 93 million miles of cold, dark space between the Earth and the Sun is between the Earth and the Sun. Not quite sure what point he's making about the Sun looking so small. So I said, well, the Sun does look small because it's 93 million miles away. And he laughed and said, no, the Sun is within the Earth's atmosphere.
What?
Yeah, oh, yeah, that's what flat earthers believe, that the Sun is some sort of big light that NASA put up during the day. Within the Earth's atmosphere. No, they truly believe this. They really do believe this. With no evidence, of course, and we know it's completely wacky. But if you talk to flat earthers, which I just can't resist establishing the facts for them when I see things like this.
Yeah.
But no, they all believe that firstly the Sun is within the Earth's atmosphere. Another thing they believe is that satellites are hanging from helium balloons put up there by NASA, again within the atmosphere.
Oh.
And I pointed out to one recently that even if that were true, how can you make a helium balloon go at 17,500 miles an hour?
Yeah.
Then you just get the standard response from them. Well, have you measured it? So you can't win with these people. They are beyond help. Anyway, moving on. Here is somebody that doesn't understand much about solar halos. It makes a perfect circle around it from 93 million miles away. So I did try and point out, no, the halo is not 93 million miles away. It's within the atmosphere, but got the usual response.
I see that's the same guy as well.
Oh, yeah, it is, yeah. Oh, yes, it's Brent Hampson. Yes, I had quite an interesting conversation with him. Now we move on to the subject of electromagnetic radiation and EM propagation. If only you could add pictures of the TVs and cars from the time and then try and convince me that we traversed space in 1969. We can't do it now because we lost the tech. No, we didn't. Can't get a mobile signal in the countryside with 5G even today, but it was radio waves. Yes, we had a conversation over 384,400 kilometers away. Apparently, radio waves travel at the speed of light through the vacuum of space. Laugh. Well, yes, they do.
Yes, they do.
They do, yeah.
Yeah. Apparently.
What can you say is somebody who just does not understand much at all?
Yeah.
Let's move on to the last one for today, Einstein of the Week. Today's Einstein of the Week. This comes courtesy of Fox News, that well-known bastion of truth and accuracy. And this was actually a news article from Fox News. Let me just read it for you. About the comet. The 3I Atlas comet was first spotted in July near Jupiter after it entered our solar system from another universe. Scientists around the world are observing its month-long journey to learn more about the chemistry of objects outside our universe. Right.
What? Sorry?
Yeah. So somebody not understanding what the term universe is, which is a little depressing in this day and age. But there you are. So that's Einstein of the Week for this week. So there you have it, guys. Einstein of the Week for this month.
Well, I will just say that I was standing underneath the moon last night.
Yes, you were.
At least it was a representation of the moon, and it was a sphere. Yep.
Really?
Yes.
Yeah. You better explain exactly what that's all about, Michael.
Yeah, it's an artwork by Luke Jerram. It's been doing the rounds. It's a several meter wide model of the moon, and I saw it inside Tewkesbury Cathedral, Tewkesbury Abbey, I should say, last night. And it virtually filled the space of the nave between the pillars of the actual, abbey itself. So quite impressive. Yeah.
Yeah. Well, I'd love to see it. I really would love to see it. Let's just go through a few of the comments up here. Derek's got a question. Did you see the fireball on Sunday? Reported streaking northwest over Portugal, doing about 81,000 kilometers. No, I didn't. If it was going northwest over Portugal, that would be going in exactly the opposite direction from us.
Yes.
Unfortunately not. But I wish I had. It's quite a while since I saw.
Sandra said we have that comes here, so I hadn't done that.
Yeah. Derek says you must be spilling all that coffee on your keyboard. Yeah, spitting it out, Derek, not just spilling it.
Yeah.
What else we got? Sandra just says one word, which sums up everything. Weirdos. Yeah. And
she doesn't mean us either.
Yeah. Furadil Sarko Joe says, I thought the flat earthers were referring to the oceans covering 71% of the earth. They are not carbonated, aka they are flat, so the earth is flat. Yeah, something like that. You see, it depends who you talk to, Sarko Joe, because there's no one firm set of belief among flat earthers. There's so much diversity in what they actually believe and are prepared to argue. They're mad. They refuse to believe that water can curve around a sphere, whereas if you just drop water onto a tennis ball, it follows the curve of the tennis ball. But then you get onto gravity, you see, and then they would just come back and say gravity doesn't exist. So which is another thing prevalent among because they don't believe gravity exists. So perhaps they should try climbing to the top of a tall building and jumping out of the window. They'll soon find out, obviously. The Deep Burrito, thank you so much for your donation, sir. Much appreciated, as always. SpaceX going ahead with HLS and in orbit refueling, probably without NASA. Yeah, that has been in the news. I was going to do a thing about it next week, actually, talking about all of this. But basically, as you may know, because this is what I think has happened, because Trump and Elon have fallen out, they're not best buddies anymore. Trump has told the administrator of NASA, who's also the administrator of the Transport Department, who wants to integrate NASA into the Transport Department, which is crazy. But anyway, Trump, I think, told him, don't let SpaceX do the HLS, the human landing system for putting people on the moon, which they are contracted to do. And he's reopened, I think we were talking about this last week, he's reopened the bidding to allow other companies like Blue Origin to build something. And Blue Origin have said, yeah, they can, but it's not going to be ready much before 2030. SpaceX have said, look, here's a list of 49 milestones that we've achieved with the Lunar Starship, which is a vehicle that is meant to land people on the moon with Artemis 3 around 2027, although I think that's a bit optimistic. Here's what we've achieved. Give us our money for this, because it is a fixed term contract. They only get money when they produce results. What a novel concept. And they said, well, we're building it. We're going with or without NASA. So it'll be the next couple of years are going to be really, really interesting. So there we are. Yes, Sandra says the stars are fairy lights that NASA put up. I thought they only did that at Christmas, but maybe I'm wrong. Yeah, indeed. I've seen that actually put forward as a serious argument, Sandra. I don't know whether you're joking or not, but they do actually believe this. And the Deep Burrito says, mate, I'm in Los Angeles. I'm surrounded by these clowns. By the way, there's an entire 3-mile street where every store is crystals, tarot, astrology, etc.
Oh, right,
yeah. 3 miles. 3 miles of nonsense. Goodness me. Things are going really badly over there, aren't they? They really are.
Yeah.
Okay. Deep Burrito also says, remember, Trump said magnets don't work when wet. He did say that. Yeah, don't forget that. Hi, Melinda. Nice to see you. Yeah. So the Deep Burrito also says that's talking about the Fox News item. That's ChatGPT, Fox News, the bullet points of the giveaway. And Sarka Joe says, I once corrected the BBC when they had an article saying the sun was powered by fission. And I asked them if it had changed from fusion. I got a reply saying it hadn't, and they had heard. Well, at least they replied and admitted their mistakes. They don't often do that, you know.
No.
I don't know whether I've told you this before. My favorite one from the BBC was years ago in the time of mad cow disease, and they were worried it might spread to sheep and that it might affect the brain of a sheep. And they, honestly, this was on the 6 o'clock news. They put a diagram of a sheep up with an arrow pointing to its head saying brain. Yeah. And I wrote to the news editor straight away saying, thank you so much for telling me where the brain of a sheep is. I had no idea. And he wrote back, and he was joking about it. He said, yeah, I think we overdid it in the information front there. Ian says, I'm afraid fundamentalist Christian thinking is just impossible to refute. Leave them to it. I say, yeah, I agree, Ian. You can't argue with these people. The problem...
I like this one from Ian as well.
I was going to say, the problem is that we have, Ian, as I'm sure you're aware, is that it's impossible to have any conversation about anything to do with space on something like Facebook without the post being infected by a large number of people spouting this nonsense. So we have to counter it. So there we are. Roger, welcome back.
Looking at this one from Ian.
NASA may well have to bow to the new up-and-coming commercial firm.
Thinking about that, at the moment it looks like NASA getting commercial companies involved like SpaceX to do the work that NASA wanted them to do. It seems like NASA have shot themselves in the foot because the commercial companies are taking over from NASA.
Yeah, absolutely. I mean, NASA has not had its day in terms of planetary science.
Oh yeah.
We rely on NASA for exploring the solar system. The only problem is that if Sean Duffy has his way and does integrate NASA into the Department of Transport, there will be no science. And which is exactly what Trump wants, of course, because the administration, because of Project 2025 being written by fundamentalist Christians, they are vehemently anti any sort of science. And, Trump just does what they want, basically. So it's going to be interesting. But apparently Jared Isaacman is still, he's still willing to do the job if and when Sean Duffy gets replaced. Personally, I don't think Duffy will be replaced before the end of the Trump administration.
All right.
He was only meant to be there temporarily, but they're not even considering anybody for the job at the moment. He was only meant to be an interim administrator, but I think he's decided he kind of likes it at NASA because he likes rockets and bangs and explosions and things. So whatever. So there you are. Deep Burrito says, "I remember the sheep brain." Oh, I'm glad. I'm not the only one who remembers it. So there you are. So yeah, that was funny. One thing the BBC used to do a lot with science, and living in Spain, I don't really watch BBC News anymore. One thing they used to do a lot was release the preliminary results of a study that they said that they reported on as if it was actual fact.
Yeah.
And when the results of those studies were later shown to be false, if they were, they never posted or they never had another item on the news saying, no, we got it wrong. It wasn't at all. So Sandra, thank you so much for your donation, my lovely. It's very, very, very kind. Deep Burrito says again, SpaceX used NASA's archives and 70 years worth of data, just like Apple did with Xerox. Yeah, absolutely. So there we are. So yeah, thanks, Sandra. That's great. Very kind of you. And there we are. Okay, Roger, are you sorted now, sir?
I don't know. It keeps not sharing the screen.
Oh,
hang on.
You've got a technical issue. Oh,
I got a very technical. Yeah.
Okay.
A minute.
I'm getting quite a bit of crackling on the sound.
Yes, I wonder where that crackling is.
Yeah, and Ian is as well.
Right. Not coming from us, I don't think.
Not me.
No.
Not me.
We've had this before. Right. We've suddenly got sort of interference coming from somewhere. Anyway, seems to have stopped for the moment. Apologies for any inconvenience, viewers. We no idea where that clicking on the sound is coming from. It's totally beyond our control, I'm afraid. There's nothing we can do to stop that. So
right.
So there we are.
I think we're there. I think we're good.
Hey. So anyway, let's backtrack. Let's go over to Constellation of the Week with Roger.
We haven't done the gallery yet.
Oh God, no! Of course, sorry, I'm getting ahead of myself. Okay, right, backtrack even more. Let's go over to the gallery with Roger.
Yay! Okay, can we see this?
Yeah.
Yay! Right. Okay, so we've got one from down under from Michael Murphy of the Tarantula Nebula, and this is just 2.5 hours of HA, and it's just a black and white, but it's quite spectacular. Look at that.
Oh, nice.
Oh, look at that. Well done, sir.
Yep.
So I don't know whether he's living out there or what now, because
no, I think he was just visiting.
Well, he's been out there for a little while because he had posted some solar images from there. But there we go.
Yeah.
Something that we will never see from the northern hemisphere.
Yeah.
There we are.
And Derek says, I see 2 cats.
Yes.
Okay.
Is he referring to the 2 cats there, or the 2 cats?
Probably your cats, Andy.
My cats, yes.
Yeah.
I'll introduce you in a moment, Derek.
Right. Okay. So onwards, we've got one from Kenneth of the moon that he did with his Olympus camera, shot with a Sigma 150 to 500.
Oh right.
Yes. And
that's
what.
Oh, isn't that beautiful?
I like that one.
Got some mineral colouring there.
Yeah, definitely. Oh, you've got a rival there, Roger.
Yeah, okay. Yeah, he's done very well. And not only that, but he's also photographed the comet, which he shot with a Canon EF 200 with a 1.4 on there, which he didn't realize he had connected.
Oh.
So this is 30 15-second exposures. Look at that.
Oh, beautiful. Isn't it a beautiful comet?
I know. Absolutely amazing.
It's a real classic comet, isn't it, with the dust tail and the ion tail? It's it's a real classic comet.
Yeah. He's done better than me, I have to admit. So I was out doing some imaging of the comet as well, but we've got some close-ups of the moon that I did on the weekend.
Oh,
Just
wow.
Just for a bit of a change.
Oh, yeah, of course.
Nice one.
Nice one.
Yeah.
You got some nice mineral colouring there.
I know.
Yeah.
Yes.
Beautiful.
Yeah.
Well
I
done.
brought it out a little bit more on here, so we could get to see some of the different types of material there. Okay, and I got some images of the comet as well, and on 2 different nights. Yeah, the one on the right wasn't quite as clear. It was a little bit more misty, so I lost some of the tail detail as well. But the one on the left wasn't too bad.
Oh, that's very good.
Nice.
But you know, if you're taking pictures of the comet through the night, if you had that amount of time, you would see how much the tail fluctuates with the stream of it coming away there.
Yeah.
Quite fascinating. Okay, and that's our brief little collection of images that we had for tonight.
Thank you very much. Don't forget, viewers, if you would like to send us your images, please pop them in an email or attach them to an email, 1 image per email, please, and send them to gallery@spaceoddities.space. That's gallery@spaceoddities.space. Not only do you get to see them here on our Tuesday live stream, but you do have your own little gallery on the Space Oddities website to thrill your family and friends with. And the address of the Space Oddities website is very, very simply, it's https://spaceoddities.space. So we hope you'll go and have a look at the website. You can also, on the website, subscribe to a free magazine in PDF format that Michael produces every 2 months called Capcom. Has been doing it for years. And it's a lot about rockets and stuff. I think that's a fair summary. Rockets and stuff.
And astronauts.
Rockets, astronaut and stuff. There we are.
Yeah.
Excuse me, this chair is going to be uncomfortable.
The right stuff.
Yeah, absolutely. So I have to keep shifting my position because I was out walking the dog yesterday, and she's now 9 months, and she suddenly changed direction violently and pulled me over in the middle of the road.
Oh yes.
And I've done my knee in, so excuse me if I keep shifting position. Dogs, eh? So, but over here behind me we have 2 cats. So that one is Violetta, fast asleep. She was actually a feral cat who used to hang around waiting for food, and we were feeding her. There we are. She heard her name. She's woken up, and I domesticated her, and she just loves being here. She's just a normal house cat now. And the other one over there, that's Holly, and beautiful, beautiful classic tabby cats. You can always tell proper tabby cats. Do you know how you tell it's a tabby cat? Because if you look on their forehead, they've got actually the letter M written in their fur. Absolutely true. So that is proper tabby. Anyway, there's something you didn't know, maybe. All right then. So
I know a cat called Holly. Not that one.
Really?
Yeah.
Well, she had a twin who was called Ben, because we named them after Ben and Holly, that wonderful children's oblique adult animation series.
Right.
But Ben buggered off one day, and we've never seen him since.
Oh.
So yeah, those two are both these cats are about. I think Holly's 7 and Violetta's about 6, something like that. But anyway, and we've got another couple hanging around somewhere as well. All right then. So we're going to move on now. If Roger's ready, we're going to do Constellation of the Week.
Yes.
So this is our weekly look at one of the constellations. If you would like to see us do a particular constellation that we haven't done up until now, tell us about it. You can email us at any time, info@spaceoddities.space. That's info@spaceoddities.space. And we'll be more than happy to have a look. So in fact, if you want us to do anything in particular on Space Oddities, any ideas that you would like to see on Space Oddities, please do tell us about it. You can join the Patreon site, which is patreon.com/Space Oddities. Just a few £, a month. You get to chat with us, and you get lots of benefits. So patreon.com/Space Oddities. You can mention it there. Or if you want to tell us about an idea you have that you'd like to see us cover, send us an email at info@spaceoddities.space. Always lovely to hear from you. So without more ado, if Roger's ready, we'll go over to Constellation of the Week.
Okay, so are you seeing the screen?
No, it's not sharing for some reason. Oh, hang on. I can see what you're doing here. Just give me one second.
Oh,
yeah.
Was that a good idea?
Right, it's disappeared now. So
all right, I'll put it back on.
There we are, and see whether I can actually. There we go. There we are. Isn't technology wonderful when it works?
Right. So we've got a little constellation, which is what normally is done by Michael. So I thought I'd get in ahead of him. And this is Equus, the little horse. So, introduction. It's the second smallest constellation in the night sky, and is only beaten by Crux, but that's in the southern hemisphere. So I suppose this will qualify as the smallest one for the northern hemisphere.
Yeah.
So it's just north of the celestial equator, so it is visible mostly throughout the year, and is because it's currently available to see from September right through to now. So go out and spot it if you can.
Right.
So it's between Great Square of Pegasus and the star Altair in Aquila, part of the Summer Triangle. So here's a little illustration of the constellation. As you can see, it's between, well, near Delphinus and Pegasus there. Just a few stars there. The star Enanth, which is in Pegasus, is just across the way there from it. So might be interesting to see. So it was first catalogued by the Greek astronomer Ptolemy, who described it as poetically the best of a horse.
Makes sense.
And the Latin name Equus translates to a little horse or foal. And it was known as Equus Primus, first horse, because it rises just before the magnificent Pegasus comes across the sky.
No, I didn't know that.
So there we well, there we are. That's good.
Right.
So here's a little bit of mythology about it. Hippi's transformation, which is the daughter of the wise centaur Chiron, who was transformed into a mare by the gods to hide her pregnancy from her father. Oh dear.
As you do.
They do these sort of things in these things. And it was also called Celerus the Swift, associated with Celerus, believed to be the foal brother or offspring of the legendary Pegasus, gifted to the hero Castor by the messenger god Mercury.
Right.
Or there's Neptune's creation, which captivates the story of Equus as born from the strike of Neptune's powerful trident during his famous contest with Athena for Athens.
You know what this is like, don't you?
Mm-hmm.
This is like Call My Bluff with Greek mythology.
Yeah, absolutely. So although it is the horse's head, is an incomplete, because there's no body and legs. It's just basically a head.
Oh, bless.
So that's, never mind. So it's up by Pegasus. So I suppose that does help, having just a head next to a great big constellation like that. So the constellations are, we've got Kit Alpha, which is Alpha Aquilae, and that is at magnitude 3.9, 186 light years away. So
this is not a bright constellation.
It is not. It is not bright, and it is not big. So the name Catalpha derives from Arabic meaning section of the horse, reflecting the constellation's partial depiction. And it's also a binary system with a white dwarf companion. So there we are. So we've also got some variable binary stars in the constellation, Gamma Equi, which has a brightness between every 12.5 minutes.
Blimey.
Although it is only 4.58 to 4.77, so good luck trying to calculate that. So you need to be pretty clever and got some very sensitive equipment to get the 0.2 magnitude difference there.
Mind you, I
And we've
mean,
also-
there are some people who can see the most incredibly tiny variations in variable stars.
Yeah. So it's not only very, very minor, it's also very quick, 12.5 minutes.
12.5 minutes. Gosh.
Yeah. And then we've got Delta, which is also a binary system and is one of the fastest known orbital periods of 5.7 years.
Wow.
Oh, there we go. So we've got very, very quick adjustments and also very quick orbits around. And then we've got Epsilon, which is a triple star system, 197 light years away. So they are obviously like a three-body problem, so to speak. That could be interesting. So we've got a few objects here. We've got no Messier objects, unfortunately, but we do have some faint galaxies, NGC 7015 and 7040, with the illustrations over on the left to show you what they are. But they are very faint and very small, so you need some rather observatory class telescopes to be able to see those objects, unfortunately. So nothing much for us here. But we do have some exoplanets also. We've got HD 200-964, which has 2 confirmed exoplanets. We've also got WASP 90, which has only got a single known exoplanet, unfortunately for that one. And then we've got HATP 65. Oh, they roll off the tongue, don't they, these numbers?
They do.
By the HatNet project. So that's why it's called HTP 65. So it should be quite an interesting thing here. So other cultural, historical tidbits we've got from Arabics, which is known as Al-Farah Awal, the first horse. So it's obviously still in the theme of the horses there, obviously coming up before Pegasus arises. And then we've got Chinese. They call it the black tortoise of the north.
Oh, it's a tortoise now. Right.
It's a tortoise now. It doesn't qualify as a horse because obviously not enough stars. Right. So a tortoise will be quite good. And then we've got the faintness of the stars in Equus. So it's not really very, very well looked at, unfortunately, especially with those galaxies not being very bright either. So there we go. So yeah, small in size but big in story. So there we are.
Really? That's amazing.
So
I mean, you know what it said was quite right. It's a small, dim constellation, but some really interesting objects in there.
There are a few little bits and pieces. You always find something somewhere.
Excellent, Roger.
All right.
Thanks a lot, Waj. Yeah, there we are. Okay, well, I think that brings us to the end of this evening's show. As I said, we're a bit thin on the ground this evening at Space Oddities. So I think we will draw things to a close for the evening. Obviously, we would like to thank you very much for being here. Thank you so much for your donations. Much appreciated. Every bit of money that you kindly give us goes towards keeping us going as a YouTube channel. So thank you so much for that. And we hope that we'll continue to bring you Space Oddities for, well, a long time to come. So, but don't forget, you know, if you have anything you'd like us to cover, drop us an email at info@spaceoddities.space. Always great to hear your ideas. And we love your feedback because we can only improve things if we get feedback. So any comments you want to make, any suggestions, anything, just get in touch. info@spaceoddities.space, or you can join the Patreon and talk to us there. So there we are. So that's it, I think. Have a fantastic week. Enjoy your Guy Fawkes night tomorrow in the UK. And I was saying on Facebook that, if you're of a certain age, you will remember those fireworks as kids that said, light the blue touch paper and retire fast. Didn't they talk a lot of nonsense in those days? Because I lit one when I was 6 and it took me another 60 years to retire. So unfortunately, we are. They lied. I was not in. I was not in any promise of retiring fast.
Very good.
So there we are.
The old
All
ones
right,
are the
have a
best.
great Guy Fawkes night if you're going to any public shows, or indeed if you're doing fireworks at home. And Michael, you're not going out, obviously.
No, 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 no.
So Roger, will you be lighting up your sparklers tomorrow?
Or will Sparkford be lighting up?
Well,
Well, it's in the name.
Sparkford, I'm sure there will be lots of bangs and crackles and stuff
there's
around by.
there's been some
Yeah.
tonight in Stirport.
Yeah.
Oh yeah, I mean it's been on the go since Saturday,
Yeah.
really.
Yeah.
That's right. Yeah.
Yeah. So we don't have firework night here in Spain. Ours is in the summer for the festival of San Juan.
Oh yes, Ariane 6 launch tonight. Does is going.
Oh right. Okay. Great. Fantastic.
It's already launched.
Yeah. I was going to say we should tune in. There's been a launch of Europe's Ariane 6 with an Earth observation satellite tonight.
Of course, he was turning on something, wasn't it? Yeah.
Yeah. Yeah.
All right.
So
I'll watch the replay.
Yeah, so that seems to have gone well. Another success for Ariane, and we love European rockets.
Yeah.
Well, I'm not so sure about Ariane 6. I think it was misguided, but that's another story. We'll talk about that.
Ariane 5 was the beast.
Yeah, Ariane 5 was the beast. Absolutely.
Yeah.
All right, then, viewers, have a fantastic week. Thank you so much for being here. Next week on Space Oddities, we're going to be looking at the subject of radio astronomy, which is not something we've really touched in any depth. So we're going to be, Roger's going to be giving us a history of radio astronomy next week. I'll be looking at some of the modern radio astronomical observatories like ALMA and the VLA. And of course, we'll be talking about the world's biggest scientific project, the Square Kilometre Array, which is currently being constructed in South Africa and Australia, which will be a radio telescope that is 1,000 times more sensitive than any radio telescope ever built. So we'll be talking about that next week as well, because that's really exciting. So if you're interested in radio astronomy, tune in next week. Tune in even if you're not, and perhaps it might interest you. You never know. All right, then. See you next week. Take care. Have a great week. So from all of us at Space Oddities, we will bid you a very